Hello, welcome again. Now is our next session. We have now is from Moats to Slopes, how authorization and authentication impact each other. And our presenter this afternoon is Atul Tulshibagwale, got right, who is the CTO of SGNL. Welcome, Atul.
Hi, everyone. Can you hear me? Awesome. So great to be here. Thanks for attending this on this afternoon session. Try to keep it engaging. I know it's after lunch. You might, I've been at SGNL. SGNL is a very new company, so you may not have heard about it. We are into just-in-time access management, which I'll cover in this presentation. Some of you might know me as a co-chair of the OpenID Foundation's Shared Signals and Events Working Group, where I'm working on the CAPE and the risk and the SSE framework. Let's get started. The topic today, of course, is about the interplay between authentication and authorization, and let's get into that quickly. I'll talk a little bit about the challenges of authentication, and then talk a little about the authorization stuff, and how it's changing, how that landscape is changing. And so I guess everyone agrees that having MFA and unphishable MFA is sort of a holy grail. Everyone wants it, but there are big practical challenges in getting there, because where do you begin? How do you identify the first few applications that are going to need MFA? How do you manage the account lifecycle of those users? Lost authentication factors, lost phone changes and things like that. So there is a process to get there. And then to make things complicated, you really have to grapple with the question whether everyone needs MFA, because sometimes you might have a bunch of temporary workers who just need to access a cloud app for a little short period of time. Do you really want to do an MFA rollout for them? You may have a business process outsourcing operation somewhere remote like India, where you have shifts of workers changing guard every time, reusing the same computer. So it becomes a little complicated, and you want to really ask yourself the question, is MFA suited for all of these possibilities, or are there things you can do in the meantime, right, while you figure this out? And the other side of the story is that it's no longer about just being inside your data center, right? Like the moat and castle model is giving way to what I like to call the global armada model, right? Where every little sort of piece of infrastructure has to be defended on its own, and it may have very different strategies to do that. And so you need to adapt to this new model, and how do you do that in the face of sort of this new problem that everyone is an insider, right? So if you look at the news, I think about 60% of the attacks now are actually based on identity compromise, right? It could be based on credential compromise, tricking people into giving up their phishable MFA, one-time passwords, and things like that. And so basically, what you have to realize is that it's just not all about authentication, right? You may do a lot of stuff with authentication. You're still going to end up with some problems, like you're going to end up with people compromising credentials. A very dangerous thing that is now starting to happen is physical threats to people who actually having unphishable credentials to gain access to critical resources. But cookie theft is another big problem, where you've gone through the whole exchange of sort of doing unphishable MFA, but now your cookie gets stolen, and that whole session gets exposed everywhere, right? And then finally, because of remote work, you now have this situation where there's more opportunity for insiders, malicious insiders, to actually operate. There is a little more opportunity. There's probably a little more motivation to do that as well. And so what you can really do is defend yourself by controlling what is known as the blast radius, right? So assume that some compromise is going to take place. Somebody is going to end up in your infrastructure, right? Somebody is going to be able to access your applications without authorization or without, by compromising somebody's credential. How can you now protect yourself in that situation, right? And so what has been traditionally done so far is that you have this coarse-grained authorization thing, which kind of works like, you define some ways of, groups or something that say, oh, these people have access to these stuff. Maybe you layer on a few things. They need to come from a managed device. They need to come on in a certain time of day and things like that. But all of this can be termed as, coarse-grained authorization. And I'll tell you the practical problems with this, with the use of an example, right? So take a real-world example that you're, let's say, a commercial airline, and you want to decide whether a pilot can fly a certain plane. If you use the most common, role-based access control system, right, which is you have people in groups, and then those groups determine, who has access, right? It's like saying anybody who has joined the airline as a pilot can fly any plane that they have, right? That's kind of what RBAC looks like typically. And it's, another problem with RBAC today is as users move within the organization, their access doesn't necessarily get revoked because, you go through processes like attestation and all that, but they are not as effective. They're very expensive because they put a lot of work on the managers, but they're also not very effective because managers do not have, complete rationale or have the tools necessary to figure out who should and should not have access, right? So RBAC, as you can see, is fairly limited. What people do nowadays is, attribute-based access control, right? So that adds a layer because what you can do is you can decide that, oh, this pilot has been certified for this particular type of plane, and so they can fly that type of plane. So the access sort of check is going to be, does the plane's sort of type match the certification type? And then the pilot can fly that, right? And so that's kind of a level better, but it's still far away from what is actually needed, which is something like this. This is a real world policy that is actually needed, right? This is that, the pilot needs to be on duty. They need to be assigned to that particular flight. They need to have a valid certification for the type of plane that is assigned to that particular flight. We don't know what type that is going to be. And they need to be able to fly it only from the source and the destination of that flight, right? So all this kind of codifies a real world policy. And you can see that there is a difference between what coarse-grained authorization can offer you and what sort of is actually desired, right? So what is the solution in this case, right? So this is where sort of we come into the new paradigm of authorization, which is it's not sufficient to ask the question, who can do what? You need to answer the question, like, can this person or should this person be allowed to access this at this particular time? Do they have a reason to be doing this at this particular time, right? So that is the new authorization paradigm. And this is where, if you look at the sort of qualities that are desired in this new authorization paradigm, is that the authorization needs to be ephemeral. You cannot have ambient access. Just because somebody was hired as a pilot 10 years ago doesn't mean that they should be allowed to fly any plane right now. You should not have ambient access. The other thing is every request should be evaluated in context, right? A pilot is requesting to fly a plane. Well, are you assigned to that plane? Do you have the right certification? Is this the type of plane that you fly, and things like that. So every request has to be evaluated in context. And then it should be time aware. It's like, yes, you granted the permission ephemerally, but then you need to take that away when the context changes, right? And then it needs to be consistent because every enterprise is going to have a whole variety of applications. They're going to have infrastructure to all the way, internal applications and 3P SaaS apps and stuff like that. So whatever you do is, you kind of need it everywhere, right? And so this is where sort of the new thinking comes in, which is just-in-time access management. And this is something new that I used to work at Google before this, and we were thinking about these things, and some stuff was done over there. But again, we are doing the same thing in our current company. And what just-in-time authorization does is it tries to ingest all your current data into a really good data structure like a graph, right? What that means is the graph is important because you're not trying to reach out to all the sources of truth in real time, right? You're building this really highly efficient data structure to be able to answer the questions in real time. And then you're able to sort of navigate the graph using real world policies, right? So the policies become very readable because of the richness of that data structure. If you have to write policies on a relational type of data structure, the policies become very complicated. And instead, a graph-based policy becomes much easier. And then you enforce it by just traversing the permitted edges. It's very, very simple, right? And so this is what just-in-time authorization is, right? And people always ask me, okay, isn't this the same as attribute-based access control, right? And so the difference is sort of subtle, but it's important that in attribute-based access control, you're really looking for fixed attributes, right? You're looking for saying, is the sort of certification type of the pilot the same as the the plane type, right? So there is the type of the plane that is important. Whereas in just-in-time access management, what you're doing is you're dynamically constructing the combination of attributes that need to be checked for. So, for example, you're interested in flying the plane assigned to a certain flight, you need to find what the plane's type is and then look at that certification that matches that. So there is a level of indirection, there is a kind of a level of graph traversal that you can do. For example, taking a slightly different example, let's say a customer service representative is trying to access a particular customer's data, right? What you want is, hey, why is this person trying to access this data? Does he have a customer service case that is assigned to that particular customer? Does any of his reportees have a case assigned to that customer, right? So all this you can do using this sort of graph-based query. And then because ABAC relies directly on going to the systems of truth or systems of record, it becomes a little more complicated and restricted to implement it because things like Zanzibar kind of take time to get populated, and so you cannot have that real-time nature. And as a result, instead the graph becomes much faster because it's ingested from the sources of truth and it can answer queries like really quickly. And then the other thing is with ABAC is that you kind of have to do an immediate match. You cannot like traverse a graph because doing joins in real time on relational databases, multiple joins becomes really time consuming. And so instead a graph traversal becomes much easier. And so you can actually have queries that can do things like hierarchical search and stuff like that. So that's kind of the high level difference between ABAC and JITAM. And so now let's take this to the practical thing about how do you actually do this in your enterprise? Because you have maybe hundreds or maybe thousands of applications, right? They may be 3P SaaS apps, they may be internally developed apps, and there may be like infrastructure level access that you're trying to control. But what you can do is, based on log analysis, you can actually identify the cohorts that you need to protect, right? And then based on that, you can apply the access control just for those applications. And then maybe that's the opportunity for you to even prioritize your MFA rollout, that by analyzing this access patterns, you can actually identify, okay, these are the applications that really I need to protect. These are the user cohorts that need the MFA in order for these applications to be hardened. And then you can simultaneously improve the authorization policy of those applications by using something like JITAM. And then, based on the log analysis, actually you can come up with the authorization policies because you can identify the nodes in the graph that are always being used to access those applications. And you can define a policy, derive a policy from that log analysis to actually say, oh, okay, these are the nodes that I need to sort of access, or these are the nodes that define my particular policy. And then you align that with your business owners and then compliance officers, and maintain these policies again as business evolves. Like I think there was a situation where Hong Kong was sort of getting closer to mainland China, and as a result, users in Hong Kong could not have access to data of citizens outside of Hong Kong, right? Just as an example. Means a huge change to the global infrastructure, all the applications involved. But with something like JITAM, which is more data driven, which is graph based, it actually becomes much easier, right? And then obviously you want to do this all in real time, because the context keeps changing, and you don't want to wait days or hours even before you can enforce a change in the policy, right? And so these are the ways in which you can improve the authorization infrastructure. And so you can apply these decisions to both coarse grain or fine grain, right? So you can say, it's my access to the entire application that I'm controlling, which is a coarse grain kind of decision. Or you can say it's a fine grain decision, which is basically, I'm just trying to understand whether this particular user has access to this particular customer's data, right? It's a very fine grain kind of decision. So you can have this, coarse or fine grain kind of decision making, and you can allow, you can have actions that may support some sort of remediation. You can say, okay, you want to do this, it's fine. You just need to present a sort of multi-factor authentication at this point of time, right? So some of this becomes possible with something like JITAM. And then the other thing is you need to be able to audit all these decisions in real time, right? Because one of the challenges today is that even though you may have a very large sort of set of applications, the decision making in these applications may be very sort of distributed. And as a result, producing an audit of compliance that indeed my accesses are in compliance with my policy are actually not easy to obtain today. But because in something like JITAM, the graph holds all that information and all the checks are being done at real time, you actually end up being able to produce an audit quite easily, right? All right, that's basically all I had. Maybe I kind of did things quite quickly here. It's just 15 minutes.
That was great. Thank you very much, Atul. Sorry.
Thank you. Happy to answer any questions.
Yeah, do we have questions?
It was a little bit unclear as to the organization of the graph for the example policy that you would have. Is there any chance you could reveal a little bit more in depth about what that looks like?
Yeah, so the graph consists of business entities. So it's not just users and groups. It's like things like customers, things like cases, things like maybe let's say your asset that you're wanting to control is, let's say, particular AWS instances. It could be sort of those specific instances. Those the universe of those instances are nodes in the graph, right? So these are business entities that get ingested from systems of record. For example, if you're talking about your asset being the customer, the system of record could be your CRM. If you're talking about cases like customer service cases, your system of record could be your ITSM system, right? And based on that, you can create these linkages because you can say, okay, in this particular customer service case, the customer is X, and that is the same customer that is in my CRM as this other X. So now you have a node, you have a link between the node in the customer service case and the node in the CRM, the node that has been ingested from the CRM. Right? So it's a graph that covers users, groups, all the business entities and the assets that you want to protect.
Would you describe the edges in the graph as just policy? And
yeah. So that's actually, policy is like a set of permitted nodes and edges, right? So you get the context. The context is user X is trying to access asset Y, right? Now you find the node for asset Y, and then you try to find a traversal which is allowed by policy to the node that is requesting it. And so that's exactly how it works.
I have a question online here. How does this integrate with an existing ID stack, say Azure AD or Okta, SailPoint, et cetera?
Right. So the graph can be ingested from these systems of record, right? So we build the graph, and it is sort of dynamically updated, refreshed from the Azure AD or SailPoint or even ServiceNow or Salesforce, things like that. In the future, we should be able to use standards like SCIM to do this. They're not fully there yet, but we want to sort of do things using standards as much as possible.
Thank you. Do we have any other questions here in the audience? No? Well, thank you very much again, Atul. Appreciate the presentation. Thank you.
Thank you.